Hey guys, welcome to another series of lectures. I know it's been a while that I've adopted this mode of lecture and I've posted my content online. I sincerely do not want to do this again, but as they would say in my mother tongue Tamil, this series of lectures are rather Kalathin Kattayam, meaning these are rather the decree of the epoch. Now, having a little bit more understanding of what the current times or epoch demands, these series of lectures are rather meant to be a bit more palatable. Meaning, I know that I have a series of lectures on the same topic, but we would strive a bit more in order to make these lectures a bit more understandable, a bit more not so dragging. So on the topic of not being too boring or not being so dragging, I would at the very outset I would highly recommend you to listen to these lectures in a 1.5x or 1.75x, so that the lectures appear to be a bit more shorter and it is not too boring. So you can speed up these lectures and you can listen to them. These series of lectures will be on the mathematical techniques in materials research. Now, the first lecture or the present lecture is just to spell out towards whom these series of lectures are directed towards and what essentially you can expect out of these series of lectures. So, in that sense, this particular introductory lecture is rather a most critical one, so that you could judge if you are ready to get on board in this journey, because this series of lectures are directed, or they are rather designed for a specific audience, and if you fall into this audience, you are most welcome. And besides that, in this lecture, rather in this introductory session, I would also want to give you a clear idea of what is the objective of these series of lectures. So there will be two questions we will be answering. One is towards whom these series of lectures are directed, and the second question is rather what is the primary objective of these series of lectures. So let's get into it. So these series of lectures, or these lecture series rather, they belong to undergrad curriculum. So the primary audience towards whom these series of lectures are directed towards, they are undergrad learners. So what we mean specifically by undergrad learners it is rather wonderfully captured by this illustration here. So when we are an undergrad learner, we do not restrict ourselves to a specific area of our chosen domain. Rather, we expose ourselves to different area of our chosen domain. So in this case, the area of our chosen domain, or our chosen domain, is rather metallurgical and materials engineering, and there are several areas in this particular domain, and more than master students, and hugely different from that of a PhD scholar, the undergrad learners are rather exposed to the various aspects of this engineering domain. And depending on these aspects, the nature of the research that is being carried out significantly varies. So, meaning we will not be restricting ourselves to a specific research, and depending on the different sort of research that is being carried out in a specific area of the given domain, the mathematical technique that helps them to understand, to gain more understanding of that particular area of the domain significantly varies. So essentially what we want to do in these series of lectures is that we want to kind of touch upon these different areas of research that play or that form the forefront of this different area of our metallurgical and materials engineering domain, and we want to know what are the different mathematical tools these researchers in this forefront use in order to get a deeper understanding. So that is the reason why these series of lectures are rather directed towards undergrad learners. So undergrad learners basically learn about different areas of a given domain, and in the different areas of the given domain, they have their own pertinent research areas, and depending on the research areas, the mathematical tool significantly vary. So we want to rather touch upon these different mathematical tools that contribute to a given research. Now, if you are a master's student, or if you are a PhD scholar who have already chosen the area of their research, their thesis topic, now this series of lecture may not be helpful to you because we may not be going into a specific mathematical tool or a specific materials research deeply. Like I said, this will more or less be a survey course wherein we touch upon the different areas of research and we touch upon the different mathematical tools that are associated with them. So it is the way this course is rather defined, the series of lecture is defined primarily because it is it is part of the undergrad curriculum. Now, having rather spelled out the target audience for the series of lectures, I also wanted, we want to give you an idea about the primary objective of this series of lectures. Now, particularly when you consider any engineering domain, the mathematics associated with engineering, we call those as, generally they call it as engineering mathematics. It is offered to these undergrad learners from the early stage onwards. So it is generally offered to them as engineering mathematics 1, 2, 3 and 4. Now, fortunately or unfortunately, even though this particular course has the term mathematics in it and it is a part of undergrad curriculum, we will not be following the template of this engineering mathematics courses. So essentially, this course will not be an engineering mathematics course 5, or this will not be an advanced engineering mathematics course. But on the other hand, what this course will be is, we will try to rather piece in the different mathematical tools that we learned in this engineering mathematics course, and we will try to put together in the framework of material research. So whatever concepts that we are discussing or we will be discussing in these series of lectures, you might have touched upon it during your engineering mathematics courses or maybe in your school days. So what we want to do is, we want to take that piece of the puzzle and place it in the context of material research, and we want to see how helpful this mathematics tool that we learned as a part of a different course is going to be helpful in our domain, in our field of research. So that is rather the primary objective of this course. We will not be looking into an advanced recent tool of mathematics. We will not be looking for something that has not been covered in the engineering mathematics course. On the other hand, we will be taking those techniques and placing it in the context of material research. Right? So this is rather the primary objective of the course. So we have answered two questions, one for whom this series of lectures are directed towards, and the other thing is what is the primary objective of this course. Now, one secondary objective, and for me at least is rather the most important one, is that you want to rather dispel the mystery that surrounds an equation. There are some undergrad learners for whom facing an equation in the context of the materials engineering or material sciences is not so comfortable. I know there are not many such, but there are few for whom facing an equation can be a little bit intimidating. They are not extremely comfortable as they are comfortable in looking into some sort of a diagram, as complex as it might be. They are interested in looking into the so-called phase diagram and other ternary isotherms. They are comfortable in doing all those things, but when it comes to handling certain equations, they are not so comfortable with it. Of course, like I already confessed or conceded, there might not be many, but there are few who are not totally comfortable with it. So one other objective of this course is that we want to make them comfortable just to go through, to handle, to face this set of equations that you come across in the materials research. So that is one other objective of this particular course. We want to make them comfortable. We want to give them the necessary confidence to rather face the set of equation. They don't have to do this long jump anymore wherein they say the set of equation and they just skip it over. We want to, it's not that we want them to go and look for set of equations, but if and when the equations comes along their way, they are confident, they are comfortable enough to rather face those equations. So we will not be looking for equations, we will not be focusing or building up based on the different tools of mathematics. Essentially what we will be doing is, in order to achieve these objectives, in order to ensure that we bring in the right mathematical tools in the frameworks of materials research, we ensure that anyone who is a bit worried about handling these expressions are comfortable at the end of this course. The way we will be achieving this objective is, we will start from a material research or a material example, an example that is fundamentally founded on the material research, and then we will build towards the mathematics of it. we will not be handling, or we will not be addressing this course or getting into this course as a typical mathematical course. What we will be doing is our foundation would be a materials research, the different aspects of materials research, and from that we will be building on towards the mathematical aspect of it, so that you understand why we need the mathematics. So we all understand why we need the mathematics, and how, despite of being a little bit intimidating, how it can be hugely helpful. So with this, I would like to wind this introductory lecture up. So basically, first thing first, please listen to these lectures in a sped up manner. You can use 1.5x or 1.75x to listen to these lectures. I intend to speak slowly, so that when you speed it up and listen to it, it is comfortable for you to understand or grasp the content that is being delivered. And secondly, this is primarily an undergraduate's course, meaning we will be touching upon different areas of materials research, and we will be focusing on the mathematical tools that help gain good insight or a comprehensive understanding from those materials research. If you are rather a PhD scholar who has already gained that understanding, and you are looking for some niche mathematical topics and a deeper understanding of them, maybe I don't think this course will be helpful to you. You might find this course wanting. But on the other hand, you can start your own series of lectures. I'll be happy to listen to what you have to deliver. And finally, in this course, what we want to do is we want to have use your existing understanding of the mathematics or engineering mathematics, and put it in the place where it will be helpful in materials research. So this is what this entire series of lectures is going to be. Let's see how interesting and how far it takes us. Goodbye.